Fine, okay. Maybe I'm not the best at playing this game. Maybe I was doing it all wrong this entire time. But I'm a little bit bitter. I don't think the way that I was playing was wrong. So I'm gonna go make a better version of 2048 where I can be the winner. Or they can be an even better winner. That's confusing. Damn. So I was playing 2048 with one of my friends, and I noticed that their score was getting racked up a lot quicker than mine. So I started to think about what they were doing and why it did or didn't matter how much thinking or planning you had to do. And I'm going to try to make my own unique version of 2048. The objective of this game is to slide numbered tiles on a grid and combine them to create a tile with the value 2048. I'm going to talk about this in as much as a code agnostic way as I possibly can, but understand the limitations of what we're trying to do here. Depending on your language or what software you're using, your values may vary, but this solution should still work for an assortment of languages. So we're going to need about 4 or 5 objects to do this. We're going to need a global object that will contain all of the states of our game. We're going to need a world object that will control both our input detection and our grid. Our input detection will let us know which direction the player wants to move, and our grid is going to be a 4x4 grid of tiles. Each tile is going to contain a value from 2 to 2048. Now with this information out of the way, we can start programming. The first object that we want to start programming is the global object. We're going to want to know 3 different states: whether or not the game is completely done, whether or not we have won or lost the game, whether or not the player has moved the board, and the score. Our next object is going to be input detection. Now, most online tutorials will suffice for doing this, as long as you're able to determine when the player is moving up, down, left, or right. And if you're looking for the mobile controls that I used in this video, there will be a link in the description below. Basically what happens is we get the start and end position for the player touching the screen, and we'll use that to create a vector, and that will determine the direction that the player wants to move. Our next object is a tile, and it contains the value that we're going to see when playing 2048. It also contains a boolean that will let us know if it's been blocked by another tile. I wouldn't go underestimating the amount of work we have to put into this tile. Right now it's just a little, but later in the projects we're going to find that we're going to be working with it for a long time, trying to figure out the different font we want and different colors and text. But I actually enjoy that part. I think saving it for last will help us make the project quicker. The grid has control over each tile in the board, and our board is going to consist of a 4x4 array. Or, in my case, I used a 1D array of 16 tiles, which you'll see later on in the video. I had to do a bit of extra math to make that work. Working with a 2D array would make this easier to visualize, but this harks back to what I was talking about previously with the limitations of the programs that you use. Since Godot gives me the tiles in a 1D array, I'm going to just do the math because I think it's easier than having to switch back and forth between a 1D and a 2D array. We want the most control of our tiles as possible, so our grid is going to be able to draw the board after we've updated all of the values on the tile. We're going to be able to add a tile and correctly check if it's even worth adding a tile to the game. We're going to be able to check if the player can even make a move on the board. Maybe all of the tiles are filled up on the board and the player can only make certain moves. We're also going to test if we can add a tile to the board after the player has moved. If, again, the board's already filled up with pieces, then there's no point in trying to add a tile to the board. And then lastly, we're going to allow the player to move all of the tiles on the board, both horizontally, which is left and right, and vertically, which is up and down. We're going to save coding these functions for later in the video because we have just one more object to talk about, and that is the world object, which is going to combine both our input detection object and our grid object together. Just with those two objects, we're going to create a main game loop. It should sound something like this. Did the player move? If yes, we're going to add a tile and update the board. Then we're going to draw the board. If the player didn't move, we're going to skip adding a tile and just draw the board. Next is checking if the game is done. If it is, we're going to let the player know that the game is over and indicate to them to restart or if they won. but if the game isn't done, we're going to restart the loop entirely and wait for the player to move again. At this point, we should have something that looks like this, a 4x4 grid with numbers displayed. Now we have all the objects needed to make 2048, so we won't be making any more for this project. This is also a good time to make sure that your input is working correctly and that you're getting the vectors that you expect. For users who are using Godot, I would like to make it aware that the Y direction is flipped for Godot, and I'll try to show an example of that with a picture below. And with that, we can move on to the functions that we didn't complete with the grid object. And we're going to start with the simplest function. The reason we have to make this DrawBoard function is because we're going to be updating the values for each tile separately from drawing them on the screen. Most game engines are going to do the draw portion for us, but the updating is something that we have to handle. So we're going to do that by looping through all of the tiles in the grid and making sure that the text matches the value. So that when we start working on the other functions of the grid, we'll be able to test them and see the results afterward. Such as when we add new tiles to the board. We're going to check if there's any empty spaces on the board. Out of those random tiles, we're either going to assign it a 2 or a 4. With the new tile added to the board, we want to take note of two things. First, the player won't see the change until we draw the board again. And this might be the last tile that's added to the board, and the player might not be able to move after adding this tile, so we want to check if the player can move afterwards. If there are possible moves left, then we are done adding a tile to the board. If we added the tile and then the player couldn't move afterwards, the game is over. This is also true if there are no more spaces left on the board when we try to add a tile. To test this function out, I'm going to add 2 tiles to the board when the game starts. It's always a good idea to test out your functions as you make them to see if there's any bugs or any issues that you catch along the way. This will save you a lot of time in the end when you're trying to fix more complex things. To see whether or not the player is able to make a valid move, we have 2 scenarios to think about. If there's any empty spaces on the board, then the player will be able to move a tile into that space. Or if the player is able to combine tiles, then we can also say that the player has another available move to make. For the first scenario, we're just going to look at each tile to see whether or not it has a value. We're going to do something very similar for the second scenario, but because we need the X and Y values, we're going to iterate using a double for loop. Again, we're using that array math to get the index of the tile we were using because it's a 1D array. And we're going to test if that tile can combine with another tile in every direction by passing in the X value, the Y value, and the actual value of the tile. We're going to test every direction by either adding or subtracting from the X and Y values of each tile. Testing each tile is fairly simple and short. Since we're testing every direction for every tile, we want to make sure that the direction we're in, or the tile we've chosen, is inside the bounds of the board. So it's within that 4x4 grid. If the tile that we want to check is within the grid, then we can check if both the values match. Our next step is to move all of the tiles on the grid. The first thing that we want to do is reset the move state in the case that we made an invalid move or we didn't actually move any of the tiles. We're going to move the tiles in a specific order depending on the direction that the player wants to move them. In a downward direction, we're going to start with the third row and move upward. In an upward direction, we're going to start with the second row and move downward. In the right direction, we're going to start with the third column and then move left. And with the left direction, we're going to start with the second column and move right. We shouldn't have to worry about empty tiles. Instead, we're just going to swap the empty tile with the tile that has a value. With the X and Y value of that tile, we're either going to move it horizontally or vertically. Once we've moved all the tiles that we needed to, we're going to say that none of the tiles are blocked. Moving vertically and moving horizontally work the same way but in different directions. And we've gathered the X, Y, and the direction as a -1 or +1 to use in this function. And to make the code more readable for myself, I added some variables with the calculations up top that we're going to use shortly. The old index is just the formula we've been using before to calculate the normal index using the X and Y. The new index is the same equation, except we've added the direction to the Y portion. And then I grab a reference to each of those tiles with those indexes, just to save myself some time. The first thing that we want to check is if the new and the old tile have the same value, if they match, and whether or not they've been blocked by another tile. With that, we can simulate combining them together by resetting the old tile to 0 and just doubling the new tile's value. After which, we're going to check if that new tile meets the winning criteria for the game. We're going to set that new tile to blocked so that we don't write over it as we continue to combine the numbers vertically. And then we're going to set that the player has moved. The second case in which we combine tiles is when the new tile is empty or has a 0 value and the old tile has a value. It's going to be very similar to the first case, but with this one, the tile won't be blocked by an empty space, or because it has an empty space, and we still set the player has moved. And to tie it all together, we're going to use a recursive function, which is a function that calls itself. The pitfalls with using a recursive function is that if it doesn't work correctly, or you forget to add a case where the function exits itself, then you're just going to end up with an infinite loop of calling the same function over and over. So the stopping case for our function is going to be when the direction is out of bounds, or the new tile is going to be out of bounds of the grid. And we do that by adding the direction to the y and checking for it. Once the function has moved as far as it can, up or down, then the function will unwind itself and stop. This will be a good time for us to stop and check our work. If everything works correctly, you should be able to swipe up and down to see that you're adding tiles to the board and that they're combining together with each other. We are so close to being done making our basic form of 2048. All we have to do is do the exact same thing that we did for the MoveVertical function, but on a horizontal axis. I'm going to give a quick summary of how that goes and show a quick clip, but it's basically the same thing. For moving horizontally, we have the same 4 variables that we used last time: the old index, the new index, the old tile, and the new tile. In the first case that we want to check is if the new tile's value and the old tile's values match, and whether or not they are blocked. After which, we're going to reset the old tile back to 0. We're going to double the value of the new tile and check for the winning score of 2048. And then we're going to set the new tile to blocked and set that the player has moved. The second case is if we're moving a value onto an empty space. First, we're going to set the new tile's value to the old tile's value, and then we're going to set that old tile's value to 0, after which we'll set that the player has moved. Again, we come across that recursive function, just a function that calls itself, and it needs to be able to be stopped by something. In our case, this function is going to stop when we have reached out of bounds in the x direction. The function will eventually stop because we're going to continue to add the direction to the x value every time we call it again. And again, we're going to check our game to make sure everything is working the way we intended. By now, you should be seeing both a horizontal and vertical movement with tiles combining and being added to the board. As far as writing code for the logic of 2048, we are done. And we can move on to my favorite part about making games, the polishing, the making it look good and fun, adding new mechanics and testing out the feel with other players. But before I show you what that process is like, I wanted to share a comparison between the original 2048 game on the web browser and the one that we've created. Some things of note between the two are the color scheme, the animations for the tile, which make the game look a lot smoother when moving them, and the score. All of that combined really brings 2048 to the next level and creates a really great experience for playing the game. Until our version of 2048, or at least my version of 2048, is at that level, I'm going to celebrate by sharing it with my friends, to ask them what they think of my progress so far. And I advise you do the same, because it's a great way to gauge the interest of what you're trying to make. The more you share your progress and all the things that you're going through, the better game you're going to be able to create. So check this out. Already messed up this entire video because right after I said I was going to show it to my friends, I started messing around with it and tweaking with it a little bit more. I kind of addressed some of the color scheme things that were going on. The red and the purple really were a strain on the eye, so I wanted to change it to my favorite colors, at least, like a more green themed. Also, I replaced the score with a timer because I wanted the game to be a little bit more fast-paced, and I wanted to drive the player to continue swiping on the tiles until a problem occurred where they actually had to think about which direction they needed to swipe. Now it's time to pick some victims.